All right, so this is the performance and maneuvers worksheet. So to start off with the VAVG diagram and what it represents. So I've drawn it here. So to start off with the positive limit essentially starts off with kind of this the barrier between the green and the orange area that's represented in that diagram. Um, so we have the positive limit, and then we also have the negative limit, which is also represented kind of the barrier between the orange and the green right here as well. And then we have the positive ultimate limit, which is the barrier between kind of that red and orange area right here. And then we have the negative ultimate limit on the bottom of the diagram that is between the red and the orange as well. And then we have areas of structural damage. So that's kind of represented here in these orange areas that are just kind of lightly colored in. Obviously not orange on here, but represented kind of the darker represents the red, and then these kind of lighter is the orange. Right here is the green, and then this is like the yellow. And then we have the areas of structural failure, which is represented by this darker color by the red. We have the areas of structural failure here. And this is our maneuvering speed, is kind of when we get into that area of green, as well as the maximum positive lift capability is right in here. Then we have the maximum negative lift capability, which is at this point of the diagram. And then we also have the limit airspeed, which is represented by kind of the joining of that orange and red right there for that diagram. And then to kind of go into the second question to describe at least three things that might occur if you exceed the limit airspeed. So three things that could occur is that the flight controls may lose their control or their effectiveness at best. Also, a stall could occur and be very difficult to recover from, and even in some cases impossible. As well as the aircraft could experience some structural damage that could be extremely damaging. And then for number three, so the graph that encompasses the typical power available, the curved line, and the typical power available in the curved line for jet engine aircraft, as well as propeller driven aircraft, as well as the power required. So we've got here this diagram of the thrust and velocity. This curve here would be the thrust available. This curve here is the power available, and then this is the power required, and then this kind of constant line here is the thrust available. And then to kind of describe that, so reciprocating engines gain horsepower with velocity. So the power that is then available starts to decrease when the velocity increases. That was represented there. And then when reciprocating engines have the best power available, there is a best airspeed option. Jet engines provide that constant thrust that was represented here. And so the same amount of thrust is always available. The best rate of climb, for example, is available at any thrust or velocity. And then when the difference of the available power and the required power is the greatest is when the best rate of climb will be achieved. And then to answer number four, so when flying a jet aircraft, describe how the thrust required curve shifts when you have a change in weight and a change in altitude. So with altitude, so required thrust decreases at higher altitudes because of a decrease in the parasite drag, and it's due to the lower density of air that's experienced. And then when the curve moves down, the crossing section of the available thrust will also move, and the available thrust will move to the right. And then required thrust for a given speed will decrease. That will also move to the curve to the right. And then at lower altitudes, the thrust increases because of an increase in drag. So essentially the opposite, and now the air is more dense. The curve goes up, and the crossing section of the available thrust will also move, and then the available thrust will move to the right, and the required thrust for a given airspeed will increase and move the curve to the left. With an increase in weight required more, so with an increase in weight, more thrust is required. So the crossing point of the available thrust and required thrust move to the left, and the required thrust for a given speed would increase and move the curve to the left. And then a decrease in weight requires less weight. So the crossing, again, kind of the opposite as the last one. So the crossing point of the available thrust and required thrust moves to the right. The required thrust for a given speed would then decrease and move the curve to the right. And then number 5, how does the power required curve change during turning flight versus straight and level? So to maintain altitude in a turn, because vertical lift is essentially being traded for horizontal lift, and as well as there's an increase in drag, more thrust would be required naturally to kind of trade off for the loss of, or for the trade vertical lift for horizontal lift, as well as the increase in drag, so therefore more thrust is required. And that's it.